Today, we're going to look at our world in a totally different way, as a giant stage, with all of humanity as the players. It's this one simple idea that actually connects everything, from our climate to our culture, and we're going to break down exactly how it all works.
So let's really dive into this concept, the stage. That's the Earth itself. Its climate, its geology, all the physical rules that we have to play by. And the players? Well, that's us, living out our lives on that stage. What we're exploring today is that constant, really complex dance between the two, a dance that can build entire civilizations and sometimes bring them to an end.
We're going to tackle this in 4 acts. First up, how was the stage even set for life to begin with? Then, we'll follow the players and see what pulls them to certain spots. After that, we'll look at what happens when the stage itself gets chaotic. And finally, we'll hit the biggest question of all. How do we keep this show going?
Okay, so how is this stage set for life? It really all boils down to one critical process happening in our atmosphere, the natural greenhouse effect.
You see this question a lot on exams, asking you to explain why this effect is so important. But instead of just listing off facts, we're going to walk through the whole thing, step by step, so you can build a really rock-solid answer.
It all starts with the sun. You've got this high-energy, shortwave radiation that travels 93 million miles to get to us. Our atmosphere pretty much lets it straight through, and it gets soaked up by the land and the oceans, warming everything up.
Now, the Earth can't just keep soaking up that heat forever, right? So it radiates that energy back out towards space. But, and this is the crucial part, it's not the same kind of energy anymore. The planet sends it back out as lower energy long-wave radiation, and that interacts with our atmosphere in a completely different way.
And this is where the magic happens. That outgoing long-wave energy doesn't all escape. Gases that are naturally in our atmosphere, like water vapor and CO2, are perfectly built to grab it. They trap that escaping heat, acting like a giant thermal blanket wrapped all around the planet.
So what's the result of this thermal blanket? It keeps our planet's average temperature at a nice, comfy 15 degrees Celsius. Without it, the Earth would be a frozen rock at around minus 18 degrees. Life as we know it just couldn't exist. That's why it's so essential.
All right, so the stage is set. It's warm enough for life. Now let's talk about the players. What makes us move around this stage? We're going to focus on one powerful force, tourism, and what really truly pulls people to a place.
When you think about tourist attractions, they basically fall into 2 big categories. On one hand, you have the engineered attractions, things like massive conference centers or MICE facilities that are built with a purpose. And on the other, you have cultural heritage sites, places that you just can't build from scratch. And this matrix, it just nails the difference. To build a MICE facility, you need money, which means you can build another one somewhere else. They're replicatable. But cultural heritage sites, their main investment is time, hundreds or thousands of years of it. Their replicatability is basically zero. You can't just go out and build another Colosseum.
Let's look at this in action with some actual data. Here we've got visitor numbers for famous heritage sites in Rome. And just look at the names: the Colosseum, the Trevi Fountain, the Pantheon. These are all one-of-a-kind places that people travel the entire globe to see.
The data couldn't be clearer. In 2019, nearly 80% of tourists in Rome made their way to the Trevi Fountain. The Colosseum pulled in over 7.6 million people all by itself. It just goes to show you, while a fancy convention center is nice, what really draws the crowds is the chance to see something unique, something truly irreplaceable.
And if you're ever asked to describe a trend from a data set, it's simple. Look at the Colosseum's numbers here. You just have to say where it starts, 5.4 million visitors in 2012, and where it ends, peaking at 7.7 million in 2019. The story is the steady, clear increase, showing the growing power of this incredible place.
But, the stage isn't always so stable and peaceful. Sometimes, the massive geological forces that built the planet in the first place are unleashed. And here's the crazy part. It's often the most unstable parts of the stage where we, the players, have built our greatest treasures.
Take a look at this global map of active volcanoes. One thing jumps out at you right away. They are not random. They form these really clear lines and clusters around the world. And those clusters? They perfectly line up with the edges of the Earth's giant tectonic plates. That is where all the action happens.
Let's zoom into one of these action zones, New Zealand. It's sitting right on the boundary where the Pacific Plate is smashing into the Australian Plate. This makes it a major hotspot for both volcanoes and earthquakes, something the people of Christchurch know all too well.
What you're seeing here is a convergent plate boundary. It's where these two massive pieces of the Earth's crust are pushing right into each other. But they don't slide smoothly. They grind and get stuck, building up an incredible amount of pressure over years and years. Eventually, something has to give. The rock breaks, and all that stored-up energy is released in a massive earthquake.
And when the stage shakes like that, the players have to respond, and fast. These images show exactly what that looks like. You've got search and rescue teams digging through rubble for survivors and emergency field hospitals being set up on the spot to treat the injured. In those first hours and days, these actions are absolutely vital to saving lives.
And for our final act, we're going to turn to one of the biggest, most constant challenges for all the players on this global stage. How in the world do we sustainably feed 8 billion people?
A huge piece of the puzzle isn't just about growing more food, it's about wasting less of what we already have. This chart here shows that we lose or waste food at literally every single step of the supply chain. It's a massive, systemic problem.
But what's really fascinating here is where the biggest losses happen. It's not in the middle like during shipping or processing. The two largest chunks of waste are right at the very beginning, in production, food that never even leaves the farm, and right at the very end, in consumption, food that gets wasted in our own homes.
And all this inefficiency, all this waste, it has a staggering cost. It's not just lost food. As this infographic shows so clearly, poor diets and malnutrition cost the global economy an estimated $3.5 trillion every single year. That's a massive burden for the players to carry.
Which leaves us with one last big question to think about. As we, the players, get more and more powerful with technology, are we really the ones directing the future? Or will the fundamental, unchangeable rules of the stage, its climate, its geology, its limits, always have the final say?